Welcome back to Vuln Vibes. In this deep dive, we are going to talk about the platform architecture defining the DevSecOps supply chain.
Yeah, and that's a really crucial shift in focus for practitioners, for you listening. We're not diving into a specific zero-day or CVE this time. Instead, we're kind of stepping back to do a meta-analysis. We're looking at the feature set, the taxonomy of the platform itself, GitHub, and how it's presented around a really high visibility repository.
Exactly. And for our context, we're using the Comfy.org ComfyUI-Manager project. It's just so widely adopted.
The numbers are huge.
They really are. The sources say 13.1 thousand stars, 1.8 thousand forks. I mean, when a public repo gets that kind of traction, the platform isn't just a file server anymore.
No, it's a critical node, a high-trust node in the whole open source supply chain.
Right, so the architecture GitHub builds around that node. It signals the cutting edge of modern DevSecOps posture. Our mission today is to sort of extract that posture and figure out what it means for managing risk.
And the way the platform organizes its own features, it's like a roadmap to their security philosophy. If you just look at the top-level navigation, what's the first thing that just forces you to rethink the whole SDLC?
Oh, it's the AI code creation stack. It's overwhelming. This isn't some novelty feature anymore. It's a foundational pillar, and it's baked right into the developer experience. We're talking GitHub Copilot for the actual code generation, GitHub Spark for application intelligence, GitHub models for the prompt management layer.
And the MCP registry to plug in external tools. The whole thing is designed to augment code creation before a developer even thinks about committing.
Before the first commit.
And that position pre-commit, that's where the security mandate for AI tooling is being set right now. We spent, the last decade arguing about shifting security left?
Yeah, constantly.
Well, now the origin point of the code itself has shifted left, and integrating generative AI this early, it just raises these really complex issues around code integrity and, more critically, data leakage. They're now architectural concerns.
Okay, so let's break down that integrity piece first. When your source code is, non-deterministic AI generated, how does that affect our traditional security gates, like taint analysis, for example?
It just makes traditional taint analysis so much harder. If a human programmer introduces a variable from an untrusted source into a sensitive sink, a static analysis tool can usually trace that data flow.
Right. Source to sink, it's a clear path.
Exactly. But if the AI suggests code that, say, subtly misuses a framework function, or it introduces a logic flaw that's technically correct syntax but disastrous in context.
A traditional SaaS tool is going to struggle with that.
It's going to struggle. The platform has to rely more on behavioral monitoring, maybe even sandbox execution policies. It's a huge architectural challenge. You have to assume the AI's output is suspicious until proven otherwise.
But I think the more immediate risk, the more acute one, is data exfiltration, specifically prompt leakage. The sources mention GitHub models, manage and compare prompts. So if a developer is feeding complex, maybe proprietary business logic, or even worse, sensitive environment details into a prompt just to get a code snippet, how does the platform structurally protect that prompt data from being exposed?
And that's where the policy layer just becomes absolutely critical. When you commoditize prompt management, what you're really doing is commoditizing the risk of injecting sensitive context.
Right.
We could be looking at data exfiltration not through a hacked database, but through the AI service itself. If prompt isolation fails, or if that prompt content gets accidentally folded into a future training set,
It's a nightmare scenario.
the platform has to guarantee that that sensitive prompt data operates in a zero knowledge or a heavily sandboxed environment, totally separate from the general training infrastructure. It's a very complex trust boundary to manage.
And this direct link between AI and risk brings us right to the developer workflows. The platform positions AI as part of the standard process. Actions, code spaces, issues, code review.
It's all integrated.
When I see actions and code spaces in that group, that's where the high-stakes supply chain attack surface really opens up for me.
Absolutely. GitHub Actions is the CI/CD automation backbone. It often holds the keys to the kingdom.
Yep. Deployment creds, sensitive environment variables.
The power to merge code into production. So a badly configured action or a compromised third-party action, that's a prime vector for a supply chain attack. We're talking unauthorized code mods, artifact injection, privilege escalation, right inside the build process.
And CoSpaces, which is sold on developer convenience, seems to be the platform's architectural answer to containing that localized risk. Instant, ephemeral, cloud-based environments.
The philosophy seems to be zero trust for the dev environment itself. You trade persistence for speed.
So that's the core mitigation strategy.
It is. The isolation you get from short-lived, containerized environments, it limits an attacker's ability to persist or move laterally. If an engineer pulls a compromised dependency into their code space, the blast radius is, in theory, contained to that one session.
But, and there's always a but, that ephemeral environment still needs to connect to things. It still needs authorization.
The connection points.
Precisely.
Exactly. How does that isolated box get access to source control, to external package registries, and, most critically, to the secrets it needs to build and test? The platform has to lean heavily on modern auth, like OIDC, and short-lived, tightly scoped tokens.
And if the policy governing those token scopes is too permissive,
Then the isolation of the container is worthless. If you grant write when only read is needed, you've negated the benefit. The risk isn't the container, it's the entitlements it gets.
that makes perfect sense. The architectural weak point isn't the environment, it's the access model.
Yeah.
And even with all this automation, all this AI, these ephemeral environments, the workflow section still lists code review as a specific step.
It's the final human safety valve. It has to be. The architecture itself acknowledges that automation fatigue is a real thing, especially when you're looking at a massive AI-generated pull request.
You can't just trust it blindly.
Never. If the AI introduces a subtle vulnerability, or if an action is configured insecurely, that code review phase is the last chance for a human to catch it. It reinforces that idea of shared responsibility. The platform gives you the tools, but humans have to set the policy and maintain oversight.
Okay, let's pivot from the workflow to the dedicated application security stack. The platform lists three distinct things here: GitHub Advanced Security, or GHAS, then Code Security, and Secret Protection. For our technical audience, for the people focused on ASPM, what is the platform signaling by splitting these three out?
This segmentation is fundamental, and it confirms a really mature approach to ASPM. Think of GHAS as the orchestration layer, the umbrella. It provides the centralized telemetry, the visualization, the correlation you need to manage findings across, thousands of repos at scale. It's the M in ASPM, the management framework.
Okay, so if GHAS is the manager, what are the two workers under it?
The workers are differentiated by what they look for and when they look for it. Code security is your broad structural analysis tool.
So is SANS and SEA.
Exactly. It's got your SATF looking for logic flaws in your own code, and your SCA flagging known CVEs and third-party dependencies. Its job is to analyze the code and its dependencies post-commit for known vulnerability classes.
And then listed completely separately is Secret Protection.
And that separation is so critical. It recognizes that hard-coded credentials are an immediate catastrophic risk. You can't treat them like a normal bug. Secret Protection works differently. It's all about detecting high-entropy strings, API keys, tokens, credentials, and it often works as a pre-commit hook or a push protection mechanism.
So it's a privative control, not just a detective one.
Yes. It's a defense in-depth layer designed to catch this one highly damaging mistake before the sensitive data even touches the repository's history. It mitigates the risk of exposure, even for a second.
So the platform is effectively telling us you have holistic posture management with GHAS, you have structural code risk with code security, and you have catastrophic data risk with secret protection. And each one needs its own specialized pipeline. That's a sophisticated way to look at it.
It is, but I have to ask, if GHAS is the umbrella, where are its limits? Can it successfully correlate findings from a third-party DAS tool you run in a code space? Or is it really just optimized for GitHub's own services?
That's a fair challenge. And the sources suggest that while GHS provides the framework, getting that true cross-tool correlation like pulling in telemetry from a custom DAS solution, that requires the kind of integration that leads us straight to the next section.
The commercial layer.
The enterprise solution.
Of course.
Precisely. You see the commercial gating on GHS, on Copilot for Business, on premium support. And this isn't just about selling features. It implies that the advanced stuff, especially the correlation and policy enforcement you need for a massive enterprise, well, that's operationally expensive for the platform to deliver.
It reflects the cost of sophisticated telemetry. I mean, managing security for a few repos is one thing, but if you're an enterprise with 100,000 repositories, diverse policies, and you're trying to normalize findings from proprietary and open source scanners, the sheer data volume is immense.
It requires a dedicated engine.
A very advanced correlation engine, and that sophistication, the ability to provide that rapid, actionable ASPM context, that's why it's behind the enterprise license.
But the architecture isn't just proprietary. The last big section here covers community and programs, which is vital, especially since our case study, ComfyUI-Manager, is an open source project. We see the security lab, the maintainer community, the accelerator.
And these community pillars are so important. They underscore that security is a collaborative ecosystem, not just a walled garden of paid features. The inclusion of the security lab is particularly insightful for security pros.
What does that signal to you?
It signals that the platform is actively funding and enabling vulnerability research. They're facilitating coordinated disclosure and feeding security knowledge back into the system.
Can you give us a concrete example of how that adds value?
Sure. Think about a core library that ComfyUI-Manager depends on, maybe a critical Python package. If a vulnerability is found in that package, the security lab's job is to facilitate responsible disclosure. They make sure the maintainers are notified, a patch gets developed, and an advisory is published before the exploit goes public.
So it protects the entire supply chain downstream.
Exactly. It's crucial for the integrity of the whole system. It ensures that a high-visibility project like the one we're looking at doesn't suddenly become a vector for mass compromise. It's like outsourced collaborative threat modeling for the whole ecosystem.
And that really connects the proprietary features back to the health of the open source foundation. Okay, so let's synthesize this. We've looked at everything from non-deterministic code to ephemeral code spaces to segmented secret protection and community research. The main finding seems to be that the platform's architecture it's totally fused. Security is not a bolt-on anymore.
Not at all. It's an intrinsic part of the workflow and the code creation process itself. The structure of the GitHub UI reveals a really mature DevSecOps architecture where AI, workflow, and security tools are inextricably linked.
The platform isn't just hosting code.
No, it is actively shaping, enforcing, and trying to contain the risks of the modern software supply chain. Every feature we've talked about dictates a risk or a mitigation that developers and security teams now have to manage centrally.
It defines the security parameters for pretty much everyone building software today. And that brings us to our final provocative thought for you, the listener. The sources we looked at mentioned documentation for a user data security migration related to this repository. This implies complex data handling and security changes being managed not by hand, but by automated CI/CD pipelines, by GitHub actions, which themselves rely on complex platform-level configurations.
So the risk isn't just in the code being migrated, or even the AI-generated code. What new, often overlooked threat vectors emerge when the complexity is actually in the policies governing the platform features, the entitlements and configurations used to execute a critical, sensitive migration like that.
The next layer of analysis, the one we've just pointed to, isn't the code. It's the configuration policies and entitlements that govern this fusion of AI, automation, and security.
That's where the real operational complexity, and therefore the real high-impact risk, is sitting now. Something to keep in mind the next time you're reviewing a highly privileged action workflow configuration.
Until the next deep dive, stay secure.